Okay, so we are going to learn fundamental theorem of calculus. Here, we want to know what is the meaning of this. Okay, the meaning of this can have, okay, if, okay, so now if my graph is like that, this is my y equal to fx. Please switch off your mic. And this is my A, and this is my B. Okay, if, so I have a few situations if. So the integral of this it can mean area bounded by the curve y equal to fx, x equal to a, x equal to b, and x-axis. It can mean this. Afterward, I will teach you how to find. Yep, it can mean this. But if I have a curve like this, okay, this is my y equal to fx. So integral of this will be equal to, we know that area is a negative value, correct? Area is a negative value, correct? So you will represent, area is a scalar quantity, so it's supposed to be a positive value, correct? So, but you do the integration of this, you got negative. So we will say this is negative area bounded by the curve y equal to fx, x equal to a, x equal to b, and x-axis. So you have to be very careful. Where is the thing? Where is the location of the curve? So I have the third situation. If my curve go like that, for example, okay, here is my, sorry. Done? Okay, if my fx curve go like this, yeah, this is my what? How come become like that? I want this, I want this, okay. Okay, sorry, okay, I redraw the whole thing. If my curve go like this, okay, it go like this, for example. Okay, here is my A, and here is my B. Okay, so this one, for this case, it doesn't represent the area bounded by the curve. Are you clear? What happened to my Something went wrong. Okay, so this one is just mere fundamental theorem. Okay, it doesn't represent area. So this means that, okay, so I'm going to tell you the general meaning of this. Yeah, so if I have a curve like that, so now if I ask you to find integrate a to b fx dx, so how am I going to do this? Okay, so first of all, I have to do, because integration is antiderivative, correct? So I will say, therefore, I will say fx. I give another function. I use capital letter F. Fx is the antiderivative of fx. Or I can say that fx has antiderivative of fx. It's the same thing. So I will put down as a square bracket, and I will put fx here. And I put a here, and I put b here. So I have to write down this one first. Yeah, then I put down, I have to sub with b, sub with the one on top, take away sub with the one at the bottom. So that is the fundamental theorem of calculus here. Are you clear?
Ms. Do,
Yes.
what is the meaning of fx has antiderivative of fx?
That means if I differentiate fx, I will get back the small letter fx. So let us go to example 4. Let's go to example 4 in your textbook. Yeah, let's go to example 4 in the textbook. Can we? So to get a better understanding of what is this. Can or not? Yeah, let's go to example 4. You look at example 4. Okay, so if you look at the example 4, for part A, okay. So this is just a fundamental theorem. Like for example, okay, I give you example here. Example, my fx is 3x. Okay, so what is my antiderivative of 3x? So I'm asking myself, what do I differentiate so that I can get 3x? What function should I differentiate so that the result is 3x? What do you think? This is called antiderivative. So I will say 3 over 2x squared, correct? So this is by experience, am I right? Later, I will teach you how to integrate. There is a formula for you. So that means I will say the antiderivative of 3x is 3 over 2x squared. You get me? If I call you with example like that, understand? Hello? Can or not? So that is the meaning of this.
Miss, is antiderivative same as integration?
Yeah. That is called antiderivative. Okay. Are you okay? So let's look at example 4 in your textbook. Can we? Okay, if you look at part A, they give you the function as here, y equal to x squared. So this is your fx. So can you tell me, what is the antiderivative of fx? That means you ask yourself, what do I differentiate so that I will get x squared? That is called antiderivative. You have to ask yourself question like that. So this is called the antiderivative. So what do you differentiate so that you can get x squared? Yeah, it will be x cubed over 3. Am I right? So this is through experience. Okay, so therefore, I integrate from 0 to 1. Okay, so if I integrate from 0 to 1, you can write like that. If you don't want to write in words like fx equal to x squared has an antiderivative of this, you can write like that. Also nothing wrong. So x squared dx. So what I will write down is, I will write down a square bracket. Your textbook don't have, I put down like that, is x cubed divided by 3, 0 and 1. Okay, so then I sub with 1. So this will be your fx. So that's why they say sub with 1, take away sub with 0. So that is the meaning of the definite, and we call this a definite integral. Okay, so this will be 1/3 minus 0, so equal to 1/3. So in this case, it represents this area, but not always represent the area. You have to be very careful. I told you already, there are 3 situations. One situation is like that, you will represent the area. If it's negative, if it's below the x-axis, you will negative the area. Okay? Are you okay? And if it is like that, then just merely that one, it doesn't find area. It's just mere calculation. Are you okay? So instead of writing antiderivative, you can also write in what I written down here in this form, so that it gives you a better idea of it. But learn how to write antiderivative, because we want to bring you into integration. Integration is antiderivative. Got it? Okay. So everyone, are you clear? And this is called definite integral because you will find a single value. You'll find a single value. Are you okay? So now we are going into the rule of integration. Yeah, definite integration. Now, definite integration means you have the number at the integral there. Okay, should I do part B for you to see example 4? I think no need, correct? You can understand, correct? Yep. The way I write and the way your book write is almost the same. It's just that I write using a square bracket. You can write like your book, or you can write like me. It's nothing wrong. That is called fundamental theorem. Any question? If not, I want to go through exercise 4C, question 5, step by step. And these are the rules that you have to remember. Shall we? Okay. Can I? Okay, you look at exercise 4C. Okay, I want to complete all the question in exercise question 5. Okay, so the first one, part A. So every time when I do this question, I have to write down. I have to write down this. That is fx has antiderivative okay, what happened? Sorry, I pressed something, okay? Antiderivative, TIVE of fx. Or if you don't want to write like that, you can say differentiate fx. You got fx. One is a capital letter, the other one is a small letter. Okay? So are you clear? So now I write down. Integrate a to a fx dx. So this will be fx, capital letter F, a to a. So that means you sub with a, take away sub with a. So you get 0 because it's the same thing. Am I right? So that's why if you imagine this in a equation, in a graph form, you get a straight line. You have the same limit. You from limit A to limit A. So, correct? So that is how you imagine in a graph form. That is the meaning of this. So a straight line, is that an area? So the answer is no. That's why you get 0. Straight line is one dimension, so you have only length. The area is 0. Clear with part A? Can I go to part B? That is how you prove. You understand? Can I go to part B? Hello? You have to respond to me. If I'm too fast, you, okay, can. Okay, so now for part B, the fx is a constant k, has antiderivative of what? Of, tell me, antiderivative of what? What should my fx?
Half k squared.
Half k squared. Are you sure? Okay, you ask yourself, what do you differentiate so that you get k? Huh? You differentiate 0. No? Can someone give me? What do you differentiate so that you will get a k?
Kx.
Kx, yes. So you see, you want to do this part, you must know your differentiation very well. So this will be Kx, am I right? So I have to write this one down first. So therefore, when I integrate from A to B, k dx, I will put a square bracket, which is my fx here, kx, from A to B. So according to my rule, I have to sub the x with B, take away sub the x with A. Am I right? So you see here, you have the common factor of k, am I right? So can I factorize it? And I prove. Done. Are you okay? Can I move on? Okay. Okay. Yeah, I'm trying to go very slow already. Which part you don't know, you please ask. That's why I stop. The important part is this part. Every time when you do this, when I ask for using fundamental theorem, you must write this down. It's exactly like when we talk about first principle in differentiation. You get me? So the question says use the fundamental theorem of calculus. So this, the statement that I tick there is a must to state. If you don't state the statement, mark will not be given to you. Are you clear? Exactly like when you do first principle. This part is called the fundamental theorem. Are you clear? This part is called the fundamental theorem. Yes, this is a fundamental theorem, okay? So you don't bring in your integration in high school yet. Okay. So can I move on to part C? Yeah. So I move on to part C. Okay, when talk about part C, we also sure will write the first one. How do we write? So you try to write down by yourself first, then you compare with mine. The first statement you must write before you go into the question. Finish writing? Sorry, I don't know what happened. Okay, I write down like that. Or I can also write I can also write like that. You see? I don't know what happened. I also can write like this. You all hold on, I get my handkerchief. Okay, I can also write like that. Yeah, so I wrote like that. Then I write down integrate from B to A fx dx. I write down equal to the NT of small letter fx is capital letter fx, correct? B down here, A up here, am I right? So I must sub with the top, take away sub with the bottom. Okay, so that is the meaning of this. So equal to, so now I can take the negative out. Then I put the top, put B here, take away FA. Is it the same thing? It's the same thing. So this one, I can write it negative. So this one is also integrate. This one should be at the bottom. Am I right? So I write at the bottom and this one I write at the top. So this is a formula that you have to remember later on. If I switch the limit, the value of the definite integral, the sign will change. If I got negative, then it will become positive. If I got positive, it will become negative if I switch the sign. So this formula will be used in, for example, I say given integrate from A to B fx dx is equal to -5. So I ask you, what is the integral of B to A fx dx? So you will say this is equal to negative integrate A to B fx dx. And this will be equal to negative integrate from A to B fx dx. The result is -5. So you put down -5. So the answer for this is 5. That is how I apply this rule in the question. For this question, I prove the rule. This is how I apply this rule. Okay? Can I move on? Okay, so I move on now. I move on to D. So you try D first. You try to prove D first. Okay. So I will do like that. So first of all, you have to say that fx has antiderivative of fx. Okay. So kfx has antiderivative k times fx. Correct? Can I write like that? So therefore, integrate a to b k fx dx will be equal to k fx a to b. So this will be equal to k times fb, take away k times fa. So common factor is k. So I take out the k. So I fb minus fa. Close. So this is equal to k times of, this one I change it back to the integral form. So if a function you time by a number, so how do I apply this formula into a situation? So the question will say, given f integrate, for example, 2 to 5 fx dx is equal to 7. Okay, I can ask you, A, find the value of integrate 5 to 2, 3 fx dx. Okay, now if you have a look at this, I'm applying the C rule and the D rule together. So you see the limit is inverse. So now I have to revert it back. I want 2 to be at the bottom, 5 to be on top. So if I alternate the limit, then I have to put a negative sign in front. Okay, there is a multiply here. So I take out the negative 3. So this is integral 2 to 5 fx dx. So this will be equal to negative 3. Question give me the value for this one is 7. So answer is negative 21. So I'm just applying the rule. So all in question 5 of your textbook, after you prove the rule, you must know how to use the rule. Are you okay? Can I move on? Can I move on to the last one? Okay, so the last one is part E. So you will say that fx plus gx has antiderivative of can I? Okay. Are you okay? Okay, so therefore, if I integrate a to b fx plus gx dx, so I have their antiderivative. So I have to sub with A, sub with B, sorry, B is on top. Take away, substitute with A, am I right? Yep. So now, this will be the F1 I group together. The G, I group it together. Can I? So this one will represent this. A at the bottom, B on top, fx dx. Plus. Minus also do the same thing, okay? Integrate A to B, gx dx. So are you okay? So that is how you do the rule. So that is the reason. That is the reason why if I say, okay, look, I'm going to show you how to do this. I said given. Okay, integrate from 3 to 5 fx dx is equal to 10, for example. So I ask you to find the value of integrate from 3 to 5 fx plus 1 dx. Okay, so this one I will break into two. Integrate 3 to 5 fx dx plus. If minus, you just put minus, okay? Plus integrate 3 to 5 1 dx. So do you know the answer for this one? Yes, given by the question 10. So can you find the answer for this one? What is the antiderivative for 1? X. So you put x and you put here 3, 5. So then you substitute that, substitute with 5, take away, substitute with 3. So the total answer will be 12. So that is how you apply. Are you okay? So far, so good? Okay. There is one more formula I want you to take notes of, okay? That is in page 109. So I'm not going to prove that 109 of your textbook. If you look at page 109,
Can I have the word before that? I kind of missed the last part.
Okay, page 109. You have integrate A to B fx dx plus B to C fx dx. This is the same as integrate A to C fx dx. Okay, I'm going to show you the situation. Okay, now, if you have a look at this is the A, this is the B, and this is the C. So this is the x-axis. So if I continue from one point go to the other, from one point go to the other, that means it's directly go from like that. So you can do it this way. Are you okay? So this is the formula. It must be in sequence, and here must be a plus. Now, based on your just now all the formula, correct? If I give you this, if I put a minus, do you think you can simplify this? Do you think you can simplify this? Do you think you can simplify this? So I will simplify this as A to B fx dx. Take away. Now, if I change the limit, I put B on top, at the bottom, C on top. What should I do to this sign? I should put a negative, correct? I change the limit. You see or not? I change the limit. Look at the limit. If I change the limit, I have to change the sign. Yep. So now you look at here. Negative times negative, what do you get? You get positive. Am I right? So this is the same as A to B fx dx plus B to C fx dx. And you look, B on top here, B at the bottom here. So they go in sequence. So this is the same as integrate from A to C fx dx. So whatever we learn here, these are the rules. And when they say use fundamental theorem, so rules you remember. So, but if the question says fundamental theorem, it's a must for us to write down this. Are you clear? If they didn't say, then you can just use the rule. Okay or not? Any question on integration, if they have the word using the fundamental theorem of calculus, I must start with this one. So that will be your exercise 4C. All have to be done in that way. Are you clear? So tomorrow I will teach you how to integrate using formula. Any question? So that one you have to remember the formula. Any question? Go back to the last slide. This is the last slide. Or sum up. Is this the one? your graphic calculator. I would like to you to take out your graphic calculator. Okay. How to find the value? Like for example, I say 5, 10. Ln 2x plus 1 dx using GC. Okay, everyone take out your graphic calculator. Okay, go to math. You don't know how to integrate also you can do. Go to math. Go down. Look for this one, FNINT. Yes. You got that? The moment you select FNINT, correct, on your screen, it will come out this. So you put here 5. Put here 10. Type in ln 2x plus 1. D, and type this one in as x. Okay, then put enter. Then you get the answer. So any definite integral can be done by using the graphic calculator. Are you clear? Okay, what is the answer? Can someone give me the answer? Can someone give me the answer? Okay, 13.779. 13.7990616. Yeah, that is what the calculator give you. Okay, so can be done using your graphic calculator. So this is the graphic calculator skill that you must learn. Are you okay? So please try exercise 4C. Before tomorrow I will talk about 4D and 4F. So, and the whole thing. So by tomorrow I will finish teaching chapter 4. Thank you, class.